Namaste students, I am Dr. Kiran Yadav. Welcome to the digital session 2.0. This class is for DET and DET+B.Tech third trimester. The topic that will be covered in today's class is Gauss law. So the definition of Gauss law is the surface integral of electric flux over an imaginary closed surface is 1 upon epsilon 0 times the total charge enclosed in that surface. So suppose the total charge that is enclosed in the surface is given by summation Q. Here we have used a summation sign because there can be many charges that are enclosed in a surface and we have to take the total charge, so we will sum up all these charges. That's why we have used a summation sign. So phi is 1 upon epsilon 0 times the total charge enclosed in that surface. So the formula for electric flux according to Gauss law is phi is equals to summation of Q upon epsilon 0. We already know that phi is equals to surface integral of E dot ds. Okay, so we can write it like this: phi is equals to surface integral E dot ds is equals to summation of Q upon epsilon 0. Okay, if in place of air or vacuum, if we use a dielectric medium, then we will write here epsilon in place of epsilon naught. So this is the formula for Gauss law in a dielectric medium. There are some important points related to Gauss law. These are: first point is, as I told earlier, summation of Q represents the algebraic sum of charges in the closed surface. Okay, total electric flux is the algebraic sum of electric flux leaving the surface and the electric flux that enters the surface. The surface that we select to apply the Gauss law is called Gaussian surface. It is an imaginary closed surface. It can have any shape like spherical, cylindrical, etc. The selection of appropriate Gaussian surface helps in calculating the electric field. Okay? So whenever we have a charge distribution, to calculate the value of electric field, we imagine a Gaussian surface that is imaginary, and considering that surface we calculate the value of E. In the next topics we will see that how we will consider this imaginary surface and how we will calculate the value of E. So the next point is, Gauss law depends only upon the total charge through the closed surface. The value of flux phi does not depend upon shape, area of the Gaussian surface. It depends upon the total amount of charge, nature and medium. It does not depend upon the position and distribution of charges. Gauss law is not dependent upon the motion of charges. It is to be noted that Coulomb law is valid for fixed charges only. Okay, so these are some of the characteristics of Gaussian surfaces. So if the total charge through a closed surface is 0, then the electric flux associated with the surface will also be 0. So if there is no charge inside the Gaussian surface, then there will be no electric lines that will either enter or leave the surface. So in that case, obviously total flux will be 0. Okay. Whether the surface is in uniform or non-uniform electric field. Okay, if the charge enclosed inside a surface is 0 and the surface is placed in a uniform or in an electric field, in that case also the total flux from the surface will be 0. Okay, if the surface is placed in uniform electric field, then the lines of force that will enter the surface will also leave the surface at some point of the surface. Okay, so the Phi total will be phi entering plus phi leaving. Phi entering is equals to phi leaving, but sign of both of them will be opposite because phi entering is the uh, number of electric field lines which enter the surface, and phi leaving is the number of electric field lines that leaves the surface. So the total phi total will be 0. Next and very important point is Gauss law is valid only for those vector fields that follow inverse square law. Okay. Now what is inverse square law? Uh, like here, the formula for Coulomb force is F is directly proportional to Q1 Q2 upon 4 pi naught R square. So here F is inversely proportional to R square. This is inverse square law. The E electric field at a point on Gaussian surface is the resultant electric field at that point. This E is obtained by the vector sum of electric field produced by the charges inside or outside the surface. The term on RHS of Gauss law represents the total charge through the surface. For special conditions, the total flux leaving the surface can be 0. However, the value of E on a Gaussian surface can be non-zero. Okay. So there is an example of dipole. If a dipole is enclosed in a Gaussian surface, then if the total charge is 0, phi will be 0, but E will be non-zero at a point on the Gaussian surface due to the dipole. Well, if there are charges situated outside the Gaussian surface, then they won't contribute in the flux. Okay, they will not be considered in the formula for Gauss law.